In figure, BA is perpendicular to AC. So what is the one thing which I taught whenever you're reading a question? Whatever information and whatever interpretation is there, you have to mention it in your diagram. So now, when we talk about BA being perpendicular to AC, what does it mean? That the angle BAC is equal to, yes, 90 degree. And DE is perpendicular to DF. So this is 90 degree. Such that BA, okay, this is equal to DE, okay, and BF, right, this section is equal to EC, this particular section, right, this length. So let me kind of make it obvious. This length is equal to this length. Okay, guys, I hope you are able to see that. Let me make it a bit. Now, so those two lengths are equal. So we have to show that these two triangles are congruent. Quite simple. So it's very simple question. It's kind of very obvious. It's there in front of you guys. Can you think over it? How do you prove it? Okay, I hope you guys gave it a try. So I will start off with to prove, and in the working only I will write all the things that is required to prove, or let me write my traditional way. We have been given, first is BA is perpendicular to AC. This implies what? Angle BAC is equal to 90 degree. This will call it as equation A. Then we have DE perpendicular to DF. This implies angle FDE is equal to 90 degree. Okay, and what else we have? We have BA is equal to DE. And what else? BA is equal to DE. This will call it as equation 3. Then what else do we have, guys? Okay, it's kind of very confusing. I mean, not very confusing, but I'm confusing myself. I don't know why. BF is equal to EC. Okay, so I'll call this as D. Now, to prove, triangle ABC is congruent to triangle DEF. So I hope you guys have done the proof already. It's very simple. So in triangle ABC and triangle DEF, we have angle BAC is equal to 90 degree and angle FDE is also equal to 90 degree. So which is equal to angle FDE, right? This is from your statement A and B, is it not? From equation A and B we have this information. Then we have AB is equal to DE. Okay, so this is given. Then we have what else? So we have this information, BF is equal to EC. Okay, right? Is this correct? Now the trick here is we need to add FC on both sides. So when I do that, what happens? We have BF plus FC is equal to EC plus CF or FC, right? We can do this, right? Not an issue. If I just flip the letters around, nothing will happen. It's the same thing, represents the same thing. But what is BF plus FC? BF plus FC is, please look at the diagram. Yes, it's nothing but BC. And what is EC plus CF? Is equal to EF. So what can you tell from this? Well, equation, we'll call this as equation 1, we'll call this as equation 2, and we can call this as equation 3. Okay, so what can you tell from all of this? 1, 2 and 3. that these two triangles are congruent. With respect to what congruency? Is it your SSA? What is it? Which criteria are we looking at? Yes, we are looking at RHS, right angle, hypotenuse and a side. We have a 90 degree. This is your hypotenuse and a side. So therefore by RHS congruency, triangle A, I hope it's A only, ABC, yes, ABC is congruent to triangle, what else, where else, DEF, hence proved. Okay guys, it's a very simple question. All I did was represent the information on the diagram, right? It was very obvious what they're talking about, and it was very obvious that this entire length is made up of this hypotenuse and this hypotenuse, right? There are two hypotenuses, is it not? Both the hypotenuses are equal, and we have FC as common length. So if the other parts are equal, by default the entire length will be equal. So that's it. We have right angle, hypotenuse and a side which is equal to the other triangle. So by RHS congruency, these two triangles are congruent. That's it. So you can pause and have a look.